Have you ever wondered what it would be like to live on Mars? Not now, but way back in the past. What if you lived on Mars 1 billion years ago? To answer that, we need to travel even further back to a time when Mars was a very different world. About 4.5 billion years ago, Mars was born from the same cloud of dust and gas as Earth. In its early days, it wasn't a barren red rock. It had a thick atmosphere, an ocean that covered a third of the planet, and pleasant temperatures. Honestly, it might have been a better place for life to start than Earth was. Fast forward to about 4 billion years ago. This was the Noachian period, a time of intense asteroid bombardment and massive volcanic eruptions. All that activity pumped tons of gas and vapor into the air, creating an even thicker atmosphere. This kicked off a greenhouse effect, warming the planet. Mars had clouds, rain, rivers, and lakes. The rain was probably acidic, which sounds bad, but it was actually great for creating life. It dissolved rocks, releasing minerals and nutrients into the water, creating a perfect chemical buffet for any microbes trying to survive. But then, around 3.7 billion years ago, things started to change. The planet's interior cooled down, and its powerful magnetic field faded away. This was a huge problem. A planet's magnetic field acts like a shield, protecting it from the solar wind, which is a constant stream of charged particles from the sun. Without that shield, the solar wind started stripping away Mars's atmosphere, molecule by molecule. With a thinning atmosphere, the planet couldn't hold on to its heat or its surface water. The clock was ticking for Martian life. Yet, life might have still found a way. Around this time, what we call the Hesperian period, Mars might have looked a lot like Earth. It still had a northern ocean, though it was shrinking fast. And this is when something mysterious happened. NASA's Perseverance rover, exploring an ancient river delta in the Jezero crater, found potential biosignatures in the rocks. These are tantalizing clues, things like organic molecules and specific minerals that, on Earth, are almost always associated with life. We haven't found definitive proof of Martian life, but we've found its possible remains. To see what this place was really like, let's jump to Mars 3.5 billion years ago. Imagine standing by a flowing river under a blue sky with fluffy Martian clouds. The air is unbreathable, so you'd still need a spacesuit, but it's beautiful. The ground is reddish, but there's water everywhere. And in that water, countless single-celled organisms could be thriving. At this exact time, life was just getting started on Earth. It's even possible that life on Earth originated from microbes that traveled from Mars on meteorites. We've found hundreds of Martian rocks on Earth, so it's not as crazy as it sounds. But the good times on Mars were coming to an end. By 2.9 billion years ago, its magnetic field was gone. The atmosphere was getting thinner and thinner. The planet grew colder, and the water began to freeze or evaporate. Volcanoes, like the colossal Olympus Monks, were the planet's last hope. When they erupted, they released greenhouse gases that temporarily warmed the planet, melting ice and causing massive floods. These eruptions could have created underground hydrothermal systems, providing a last refuge for any surviving microbes. While life on Earth was flourishing, with cyanobacteria pumping oxygen into the air, life on Mars was forced to retreat underground to survive the harsh radiation and freezing temperatures on the surface. Okay, let's finally jump forward to our destination 1 billion years ago. What would it be like? I hate to break it to you, but by this point, Mars was well on its way to becoming the cold, dry desert we know today. This is the Amazonian period, which continues to this day. The atmosphere is incredibly thin, mostly carbon dioxide, and the average temperature has plummeted to -60 degrees Celsius. There's no liquid water on the surface. It would just boil away in the low pressure. It's a dusty, rusty, red world, but not entirely dead. 1 billion years ago, Olympus Mons, the largest volcano in the solar system, 3 times taller than Mount Everest, was still sputtering to life. Its eruptions would have sent lava flows for hundreds of kilometers, temporarily warming the area and maybe sustaining those underground pockets of life. But these were just the final breaths of a dying world. From then on, Mars didn't change much. Its surface is now shaped by wind erosion, creating vast sand dunes. There might still be water locked away underground, and we have those intriguing little spots on the rocks that hint at a living past. But for now, Mars remains silent. The search for life continues, but it gets harder. Once humans finally set foot on the red planet, we'll bring our own microbes with us, which could contaminate any evidence we find. So, while you might one day walk on Mars, living there 1 billion years ago would have meant witnessing the slow, cold end of a once vibrant world. Thanks for watching, and be sure to subscribe for more cosmic journeys.